Okay, so welcome everybody. Again, my name is Friedrich Simmel from TU Munich. This competition is held in the framework of this My Disk consortium, and our goal is to use bacteria to produce DNA and to store information in DNA in live bacterial cells. And the reason why we do this, I can briefly explain. The general idea of using DNA as a data storage medium comes from the fact that our world generates more and more data for various reasons. And it is currently, it's difficult to predict how we are going to or how we can store all that information in the future. You see that this is like an amazing number here, 175 zettabytes. In the past, nobody even knew what zetta is, but it's this huge kind of number that you can read here. And the question is whether the currently available data storage media are sufficient for that. And there are different sort of properties of different types of data storage media that you can see in this graph. Of course, everybody knows hard disks or solid state disks nowadays, flash memory, and they all have different properties in terms of DNA data density and also the access speed for the data, but also they are actually have different times of how long they can retain the information. So all of these media invariably lose information over time. So you cannot use them forever. And you need to, in some cases, just make copies of the data again and again to sort of preserve the data. And this is why people came up with the idea that maybe DNA is the perfect data storage medium because DNA in nature is used for information storage, and it is, of course, a molecular information storage medium, which means that it has an extremely high data density. So if you essentially take one base pair as 2 bits, then and you calculate the size of a DNA, which is like 2 nanometers in diameter and 0.3 nanometers per kind of base pair, then you get an extremely high data density. And this is why people thought, well, this would be ideal. You could actually store all of the world's data in a few hundred grams of DNA, depending on various aspects. But so that's roughly it. And the problem now arises actually from the fact that we are currently lacking a technology to generate such huge amounts of DNA cheaply. And therefore, and this is a graph that's maybe a little difficult to understand, but what it essentially says that currently conventional data storage methods like tape, for example, for long-term storage, is just cheaper than using DNA. So if you go to any of kind of point here in this graph, so you would need to reduce the cost of DNA data storage along the vertical line here in order to make DNA economically more attractive than tape recording. And this is how long sort of that would take you until you get to that point. And so that means that if you in 100 years or so, you could make it maybe more attractive if you really reduce that so much. Now our project is focusing on microbes and as kind of reactors and or producers of DNA molecules. And the reason for that is that the currently available technology for DNA synthesis based on either chemical synthesis or newer methods like enzymatic DNA synthesis will not be able to produce these huge amounts of DNA, likely not be able and in a cheap way. And therefore, of course, a vision is to maybe generate a new type of biotechnology that generates a lot of DNA very cheaply. And so in the same way, like microbes are already used for the synthesis of interesting chemicals, they should just produce arbitrary DNA sequences. Now, the question is whether we can generate a technology that can do that. And the vision essentially is that you sit on your computer, you generate sequences that you like or need, and then somehow there's a control unit that that tells the bacteria to produce that DNA. And there can be very different instantiations of that. And the external control could be, we currently look into light control, but it could be voltage or chemicals, or everything could be in a bioreactor form. This is not totally clear. And then the DNA, the bacteria would just generate the desired DNA and eject it by some mechanism. And then you can use that DNA. And this should be, in our context of data storage, allowed to sort of produce arbitrary sequences, of course, to store information. But the question that will now be asked to you, the participants of our competition, is whether such a technology like this on-demand production of arbitrary DNA sequences using a cheap biotechnological process can be used for something different. And with this, I will hand over to Alessandro, who will explain all the details of that competition. Thanks very much.
So, good evening, everyone. First of all, thank you very much to be online and in person. My name is Alessandro Barbarulo, and I work as an innovation manager for Day One. Day One is an innovation startup studio that is based in Italy, in Rome. And as Fritz said, as a part of the European Media Disk project, Day One is organized the first edition of the Genius competition, Genius for genetically engineered ideas for the unconventional solution. And today I'm going to describe how this competition will be in the next for the next months. So we are here because we need you to thinking completely outside the box and come up with some revolutionary and novel idea. For this reason, what we need again new in this competition. The main question is why Genius and why this kind of competition? Let's say that Genius can be a tool through which the open innovation in the project as a media NEA disk is able to create a collaboration, a network between scientists in the media NEA project, media NEA disk project that is a project already granted by the European Commission, and the student. So then it's a way to create a kind of spirits and collaboration between student and more than 20 researchers that are involved in the Media NEA disk project, giving the opportunity to the student to describe the idea, to show the idea, to see also how a consortium inside the European Commission works. And then, of course, the most interesting part is your idea can be also used for the real world use case. So you have this opportunity to have idea from the concept to the reality. So to achieve this, we need, first of all, your creativity, and second one, your completely out-of-the-box approach to thinking about new idea, new application of the technology that I will describe later. So what we are looking for exactly is you as a talent give completely new idea, and then you'll see also some other characteristic. Mostly what we're looking for is a revolutionary idea that will be novel and push behind the consortium. And the consortium, as you see before, is mostly on the DNA storage. We want something completely different from the focus of the consortium. But first question is, okay, what is the starting point? So which technology are we using to launch this competition? Mostly you can see here, the technology behind this is a bioreactor capable of growing a bacteria population with containing the DNA sequence, a DNA sequence. The bacteria can be able to receive and release DNA by some external stimulus. Can be light, can be pH, can be everything. And what we're looking for is mostly like Escherichia coli or Bacillus subtilis. The DNA length will be more around 500 to 10,000 base pair. Temperature will be between 0 and 37 degrees. And you know better than us, the efficiency of transfection is also quite important because, of course, if you have more transfection, more percentage of transfection, you have a better results. Mm. So we have this powerful technology under the development that is mostly like the DNA storage. And today we are here to mostly launch this competition. The competition will be mostly like tell us what you want to do with this idea, which kind of idea. And the idea, there will be, first of all, a part of the registration of the competition. So you will see the registration will be from tomorrow until end of the year. And then there will be a proposal submission. The proposal will be then reviewed by people in the consortium, and evaluation following exactly how the European Commission follow the proposal, review the proposal. So they mostly describe three key criteria that are impact, feasibility, and also credibility of your idea. And then when there will be all review will be proposed, all proposal will be reviewed. Then there will be a winner with the price that I will show you later. But also important things is your idea will be described, will be shared with the people inside the consortium. So let's say that the competition can be divided in 5 different stages. The first stage is today. So we launched this competition here in TUM with the student or young researcher in person and online. The second part will be the registration. Registration will be in 2 days, just give us the time to organize the dedicated web page. And then you can register for the competition. You can register, you'll see later, or as a single person, but also as a consortium with the PI or with the leader of the consortium. Then there will be a proposal deadline that will be middle of January 2026. That is at 5 o'clock Brussels times. The participant will submit the proposal, and then we start to review with the people inside the Media and Disk project until the 20th of March 2026. And then the winning participant will be informed by email the 23rd of March 2026 for a price. And then let's describe mostly the price. So the price is mostly like price for you, for the science, for the media disk project. First of all, there will be 3 different prices. First of all is €1,000 that you can use however you want. Completely, nobody, no link, no any kind of block or whatever you want, you can spend this €1,000. Then you're gonna add 3 months online incubation with the day one. If you remember, day one is an innovation studio. The innovation studio normally bring the idea from the bench to the market. So then with this incubation time, you will have a kind of boost of your idea to become from the concept to the reality. And then you can also present your idea directly to the Media Disk Consortium in the next or upcoming in-person meeting. So it's a huge opportunity because you have 3 different prices that are completely, they are important from you, for idea, for the media and disk. The phase 6, again, is the India incubation. So you mostly present your data, will attend in the person meeting with the media and disk, the winner, and then you can show and present your data for the future development. But the question is how you apply. So you will see in the website that you will see a template. This template is quite similar of the template that normally the European Commission use for the European grant. So this template is divided in 7 different parts that describe as, first of all, abstract. Abstract must be maximum 250 words. And you have to try to answer the main question that the abstract asks you, like, what is your idea? What's the problem or the opportunity this idea address? What is the role of the bacteria, the engineered bacteria in the project? And also in which kind of context you see this, your idea? Medicine, environment, and why this idea can be explored. This is just the abstract. Then there will be the most, let's say, longer part is the application description. So the application description is what specific problem, try to answer the question as like what specific problem or opportunity your application address and what makes relevant today. In which setting the application is deployed? Is it clinical therapy, for example, industrial biomanufacturing, environment sensing? How, for example, your system works. So how the DNA, which kind of stimulus can allow the bacteria to release or to uptake the DNA? And then what existing technology or solution are currently present to this problem? This is mostly like, it's called the state of art. So your idea can be new, but you have also shown us that you know which is the state of art. So you know today which is the solution for the problem that your idea is trying to address. Impact. This is another part that is quite important because no more than 400 words. The impact is how your idea exactly impact the real life. So who are the primary user of this application and what needs or challenge solve? What benefit can create? Social benefit, clinical benefit, industrial benefit. And how this contribute to a large goal or need, for example, sustainability, equity, accessibility. And then what the measurable outcome that is normally you will find also as a KPI. So some value that you can set, and this, if you are achieve this setting or this parameter means that your technology works. It's just a control of the technology. Technical feasibility. So no more than 400 words. An idea can be very good idea, but if lack the feasibility is more complicated that come and arrive on the market. So mostly is what is the development stage of your concept? Is still an idea, a proof of concept? You already test, you already have an integration is in a system, and then is which part of the system is already present and which one is already as a experimental setting or speculative setting. And then also, what are the main technical constraints? Safety, scalability, containment. For example, we know that the gene therapy is an amazing idea or is an amazing approach, but one of the main problem is the scalability. So it's exactly the same. So you find the idea, and then you also identify the bottleneck and the technical constraint. And this is quite important because as you can show to the people that say, look, I know the idea, I know that this idea has some problem, but I also know how I can solve this kind of problem. And then, of course, the originality of the idea. Again, an idea can be amazing, but if it's no original, doesn't do nowhere. Maximum length is 300 words, and then it's mostly like the novel, concept novel in terms of function, mechanism, context. You are solving a problem that is already present, or is you are solving a new problem that come out and solve with your idea? And then is an unconventional combination of idea or is a unique perspective of the idea? And why do you think that this idea can work and can be explored? And this is the originality of the idea. And then a preliminary market analysis. Again, an idea can be amazing, but if you don't have market, there is no chance that can be used and useful. So in this case, maximum length is 400 words. And the main question is mostly the potential market in Europe, but also potential market in US, and also if you can qualitative or quantitative also parameter to describe the market. The stakeholder that are the key stakeholder of this project or this idea, so the people that are most involved in this idea, like founder, partners. This stakeholder is part of the large organization, small actor, mix of organization, and also the market. There is just one big stakeholder, or there is different people that work in the market. And what barrier to entry in the market exist? Regulatory, economical, cultural, and how you can address this problem. And then the last part is the future vision. So of course your idea is now, but it will be applied in the future. So this is no more than 300 words. They say, okay, how your solution can be scale up or adapt to other case, can be a large platform, a system or an ecosystem, and what is the long-term potential of your idea. This is the form that you will find on the website as a template, and you can just fill following the main question. So just to summarize everything. So the registration starting this Wednesday, the 15th of October, until end of the year, 31st of December 2025. The eligibility are welcome from both individual applicants, but also team. Of course, that inside, as I said, inside the teams, you need to describe and show the API that's also gonna get the price, gonna get everything, also the online meeting and also in-person meeting. The proposal submission deadline is middle of January, 15th of January 2026, and the winner announcement will be the 23rd March 2026. Price, again, €1,000, 3 months incubation with day one online to boost the idea, to be able to show the idea and became more real idea. And then in-person meeting with the media this consortium in the next coming meeting. And how you're gonna register? So you can follow the website, go to the website, and then fill the registration form to officially register to the competition. And then, of course, please follow the Media and Disc link page to get regular update on the status of the competition. And you will see then also the name of the winner person the 23rd of March. So if there is any question, please let me know. And thank you very much.
Switch on the microphone if there is a question here. Okay.
Yeah, there is one question from here online.
Yeah, question. So about like the project as is, right? You have the microbes that produce the DNA, and once you start implement the microbes into a system, should we implement like the microbes themselves, or like the DNA as a product from the microbes?
You can mostly, the idea is you can improve, or you can have the ability to create something with this DNA. You don't have to improve the ability of the bacteria. You have to mostly, or if you can in the idea is good, but mostly we wanna see if the application of the system where the bacteria can introduce the DNA.
Sure. Should we take the bacteria as a whole and put them into a system, or should we just take the DNA produced by the bacteria and put that into a system?
No, you can also take DNA outside and put in the bacteria and grow the bacteria and thinking about the bacteria and with the DNA in the setting.
Sorry, I didn't quite get it. So let's say I have a great idea. Do I have to use bacteria at all in my idea? Or can I just say I don't care about the system produces DNA, and my idea starts from the DNA onwards, but has nothing to do with bacteria anymore?
No, there must be the bacteria must be part of the idea.
Okay.
So, and the system together, DNA and bacteria can be then, of course, yes. There is one question from we'll have protection on our idea, so can not be taken. So the protection will be mostly as in the consortium. When we have this idea, there is a consortium agreement for the protection of idea, and then there will be also part in the part of the idea. The protection of the idea will be then shared with the people in the consortium. I don't know if there is other question.
I can ask a question.
Yeah.
As you know, the problem with this technology is reading and writing speed in terms of using this idea, this substrate as a storage. So as you know, there is a limitation for reading and writing, and for me, it's a bottleneck for defining a project. So how we can address this problem?
But something that I will like, maybe I was a little bit messy with the DNA storage. It's must be completely outside the DNA storage and the idea of the again storage the information by the DNA. Mostly is the idea about the bacteria and the ability to introduce and have this DNA inside the bacteria and release and apply for also not only for the storage, but also for medical part or, I don't know, environment control and biosensing. I don't know if I reply to your question.
Yeah, thank you.
Yeah, okay. Other question from online? No? Okay. So thank you very much. And please, if yeah, follow the update then with the for apply and starting for the thinking about the idea. And thank you again. Bye. Yeah.